Good morning. Thank you, Josip, for your kind introduction. It's my pleasure to be here on this beautiful island, and I want to, first of all, thank Softcom 2024, Josip particularly, for your kind invitation. I want to thank Green Edge Project, Michele, for your invitation. It's my pleasure to be here. Uh, I would like to talk about this sustainability in communication systems, and particularly what we call truly sustainable system, just to make some sort of difference between sustainable and systems and truly sustainable. And I will return to this in a short while. Um, Maybe I'll say a few words about myself, my work. I am a member of this 6G flagship, and I am working these days on optical wireless communications and radio communications. And particularly, I'm very much interested in these sort of hybrid networks, optical and radio. And also I work on 6G architecture, and I work on in-body communications using optical systems, but this is another subject. But before starting, also some background. We started at the 6G flagship some years ago, some activities regarding sustainability. We wanted to have internal discussion about sustainability. I created what we call it a sustainability task force, and we started to discuss about this and come up with some. We came up with ideas, and then things. And we wanted to actually do things not only from the theoretical point of view. We wanted to build and demonstrate that that communication systems can be done in a sustainable way, like in a wide sense, sustainable. So now I'm going to my presentation. So basically, I will spend maybe half of my presentation talking a little bit about sustainability in wireless communication systems, some definitions, things that we understand, and this wide sense or maybe holistic approach to sustainability that we are advocating. And then I will talk about the Super IoT project, which is an ongoing SNS project, European project, which is basically trying to do what I will be talking about, how to make a sustainable system, a wireless communication system, which is truly sustainable. And this is a project that started last year, and we are now in the middle of that project, and I am the coordinator. And so I will show you like how this truly sustainability can be achieved in some way. Yes, let me start, and I will start with this vision that this was sort of vision that the 6G flagship has been using for a while, showing like basically we are saying that by 2030 we will be living in a data-driven society. We will be really fully connected with near instant connectivity and unlimited in terms of capabilities. But this is a very nice vision. But there is something that it is not necessarily seen here, and there is something that hasn't been seen in previous like wireless and mobile communication in the past, when we talk about the generations from the first all the way to the fifth, and now the upcoming sixth. And this is actually on one hand, this connectivity will make this work moving, will make this move more sustainable. We will be connected by an array of different networks, wide area or cellular, short range, satellite, terrestrial, non-terrestrial, you name it. But there is something. How much do we have to pay to get such a connectivity? On one hand, to make our world more sustainable, but then are those systems themselves sustainable? This is the big question, and in my presentation today, I will try to see this particularly from the wireless communication system point of view. How can we engineers what can we do to make those systems, future systems, more sustainable? And I think that if we consider like previous generations, and everything has been driven by performance, but now it's time to include into this equation, so to say, also the price to get such a performance, which we have to be extremely conscious about how much we pay in terms of use of resources. Also, I would like to share with you a couple of nice definitions, just to think what is sustainability. Sustainability is a very complex and multidimensional concept, and I think that this in the upper part you see this definition, which it's very compact, but captures the essence of sustainability. Sustainability is the principle of ensuring that our actions today do not limit the range of economic, social, and environmental options open to future generations. So whatever we do today will have an impact in the on the future generations, and so we have to take that into account. And also related to this is the sustainable development, which is the development that meets the needs of the present, needs of today, without compromising the ability for future generations to meet their own needs. So these are kind of the same thing. So in general, when we talk about sustainability, I think there are these three aspects: the economic, the social, and the environmental. And I have just a few slides to give you the general framework of this sustainability. And I'm sure that you are familiar, you have seen this picture, like these United Nations Sustainable Development Goals. They have agreed on a framework for sustainable development, and they have identified 17 goals, which are those listed here. Within those, like 169 targets. The achievement that you can get with this can be measured using 231 indicators. And of all of these, there are 7 ICT-specific indicators in this UN Sustainable Development Goals framework. Probably from our perspective, the most important is, even though all are important, but as you will see from my presentation, like this environmental sustainability, the ecological footprint, how much we use land, how much we consume water, the carbon footprint, the greenhouse gas emissions, carbon neutrality, decarbonization, net zero. This one, the next one is quite, sorry. This one is probably quite familiar. We are quite familiar with this, the use of natural resources, resource efficiency, energy consumption, use of renewable energy. We will return to this, but also materials, waste management, circularity, recycling, durability, and then how we measure, how we assess the environmental impact. This carbon footprint on one hand, which is measuring the environmental, the negative environmental impact on one hand, and then we have the hand footprint, which is assessing the positive impact of whatever technology, in our case, communications. Then we have the social sustainability, which is more related with these social issues like availability of resources for a good living, like including everything that you can imagine: food, health, education, income, work, equality, human rights, trust, security, affordability, fairness, and so on. And also, and this is related to communications and digital inclusion, even though I'm not going to touch about this, but this digital inclusion, how to create or provide affordable access to digital service to everyone, regardless of where they are, and so on. And finally, the economic sustainability. I'm also not going to talk about this, but it is an important one at corporate level, ecosystem level, society level. And so all the growth should be sustainable. So it has a cost, and we need to be aware of this. And also related to this are the business model that we create for whatever technology we come up with, and so on. Let me continue with this. This has been relatively recently, this chart of the capabilities of IMT 2030 proposed by the International Telecommunication Union, where we can see the enhanced capabilities and the new capabilities. Probably you are familiar with these. On the other hand, on one hand, we have these the enhanced capabilities of performance measures that we are familiar with, like latency, reliability, security, density of connections, and so on and so forth, spectrum efficiency. But something which is interesting is these new capabilities. So including coverage, sensing related capabilities, application of AI, interoperability, positioning, but I highlight this sustainability. This is the first time that we see it like officially sort of. And this is giving a hint that because the 6G will be based on this recommendation, and now we see sustainability and how much we will see and how do we need to understand this sustainability. This is an interesting issue, and I will be talking a little bit more about this. Now I come to just a short kind of comparison between when we talk about wireless communication systems and sustainability. So on one hand, we can think about the wireless communication system for sustainability. That means how whatever wireless communication system, from a completely new to some part of it or pieces of it, how these are supporting a sustainable world in the three senses that I previously described. This has been well defined, as we saw previously, by UN, and we have the Sustainable Development Goals for that. On the other hand, again, the other way to see is like this wireless communication systems have to be sustainable. So sustainable wireless communication systems. So whatever system, part of them, components, everything should be sustainable. On one hand, on this wireless communication system for sustainability, since they help to make this our world more sustainable from the economic, environmental, social point of view. So we can see the wireless communication system as a part of the solution. But how about the system, communication system itself? If we don't deal with the cost, environmental cost of those, the wireless communication system could be a part of the problem, because on one hand, we would try to make the world more sustainable. On the other hand, we propose a solution which consumes, again, resources, and this could be, the amount of resources could be considerably high. And so we need to understand this part, and we need to ensure that the wireless communication system is also a part of the solution, not a part of a problem. So what in general, when we talk about sustainable wireless communication, what do you mean by that? In the past, we have been using mostly energy efficiency, low power solution, zero energy system based on energy harvesting, also spectral efficiency. These are very important things. But also, if we think in the past, personally, like 10, 15 years ago, most of the papers we were working, we were always referring one way to another to green networks, green communication. Everything was green. What did we mean by that in general? Like 15 years ago, green networks were talking about this. And the thing, and this kind of started our discussion in Oulu regarding sustainability, is like, even though all this energy efficiency and energy in general, efficient use of energy is extremely important, it is not depicting the whole picture. We need to see it much wider, because we see that today, when people refer to sustainability and sustainable wireless communication system, they, in one way or another, only focus on this. Again, I'm not saying that this is not important. It is probably the most important, but it is not the only thing. And if we want to maximize or if we want to minimize the environmental impact, we need to see sustainability from a much wider perspective, not only energy. And this is like the message. And when we talk about truly sustainable, we refer to systems that follow a sustainability approach, which is more like holistic, where energy are part of the thing that we will consider, but the focus is not only on the energy issues. And for that, we have been using this very simple model, and we have the stages of a wireless communication system. And if you see here on the axis, we have, this is the timeline, and we start with the system development. Then after that, we have a useful life and then end of the life. Like every system, network or part of it, even a component, everything follow some sort of this stage. So, and when we think about the system development, we start with a design and the design receives inputs, typically technical requirements. We need to make a network able to do this and that, or we need to do whatever, a circuit, a modulator, or this or that. It doesn't matter at this point. But we expect that in the future, today we don't have this so clearly established. We don't have any standard related to sustainability requiring that the system has to have to be this and that sustainable. But in the future, we expect that this will happen also. But we design, then we implement, then during the useful life, mostly we will operate the system. But of course, every now and then we may have to do some maintenance. Every now and then we may need to do some modifications or reconfiguration. Some reconfiguration could be dynamic based on the use, but some modifications or repurposability or things like that could also happen. Maybe if there is a change in the standard, I don't necessarily need to throw away my system, but maybe by software I could eventually modify and change the system. And then at the end of the life, we have a disposal. Of course, sometimes we may have also here like repurpose this system to be used in a different way, but because it is flexible, we can do it. I think that anyway, this holistic approach that we have been using is, let's consider these 4 stages and let's consider sustainability at this phase. So the system should be sustainable by design, by implementation, by the usage, and then we should be able to have a sustainable disposal. I want to highlight the most important part of the whole thing from the point of view of sustainability, and if we want to minimize the environmental impact, it is here at the design. And it has been estimated like 80% of the environmental impact is determined already at the design phase. So because at the design, you can imagine I can have impact on every other things, even in the implementation, even in the operation, if I do it properly, even at the disposal, because this is also related to the implementation. And I will return to this, and I will show you later when I talk about the Super IoT, how the project is working in this aspect on each of these stages. And here I have also an example about, this is more related to mobile phone technology. It has been also estimated that 80% of smart, sorry. Yeah, 80% of the smartphone environmental impact is produced before a device reaches the consumer. So when you buy your new phone, already 80% of the overall expenditure impacting the environment has been already used in the design, in the manufacturing, and then you probably, by consuming energy and using services, this and that, you will consume 20% of the overall energy. So, and there are many hidden things like the hidden environmental toll of smartphones. And here there are some sort of examples. This is not comprehensive. The energy required to manufacture a smartphone. Do we see it as a consumer? We don't see. The environmental cost, extracting materials and minerals from mobile device. We don't know about this. The social impact, it has been discussed nowadays, a lot of discussion about these sort of materials and minerals coming from conflict zone. People are even fighting because of those. And one thing is, when we think about the smartphone, the most important thing at the selling point today, from manufacturing point of view, is performance. And also for us as a consumer, when we go and buy a device, what do we see? Performance, is it able to do this and that, like support the data rate, support these things, things like that. Brand has an important weight. The design, maybe the physical design, price. But do we have any sustainability figures, some sort of showing green values about this? These are not provided. I cannot, in general, nowadays, some manufacturers talking about sustainable devices and this and that, but this is not like the main trend today, and we as a consumer don't have any means to consider and to buy based on this and make our buying decision based on sustainability. So here, just of these four rules that we discuss about holistic sustainability, sustainable by design, what can we do being like communications engineer? Of course, these are not, again, comprehensive, but just to give an idea about if we want to make energy efficient communications, we can study at link level, like modulation schemes, resource allocation, passive communications, wireless energy transfer, and so on. At the network level, we can study like energy efficient MAC protocols, energy efficient resource allocations in general, routing, wake up techniques, wireless energy transfers again, and others. Also spectral efficient communications at link level, modulation scheme, resource allocation. At network level, frequency reuse schemes, resource allocation again. Also, the use of optical wireless networks, which is not using the radio spectrum, is an interesting option. Also, the optical wireless communications reuses the lighting infrastructure, which is also a sustainable way of seeing this. From the point of architecture, we could study how, if we have several networks, how can we select the network from a sustainable sustainability with the sustainability criteria. If we select this network, we will consume this amount of resources. If we prefer another one, we may consume more or less, and we need to be conscious about this. And nowadays, and more with 6G, there will be a large array of different networks to choose from. Also at the design phase, as I said, we can talk about reusing the infrastructure, and one example was reusing the lighting infrastructure. Today, more than 50% of the lighting indoors is based on LEDs. In 2035, predictions say that there will be 95%. So we have there already more than 50% in the future. Almost every indoor will be illuminated by LEDs, meaning that we can also have connectivity based on visible light communication. So this is reusing the infrastructure. Flexible and adaptive solution. The same solution can be used. We don't need to design different solutions for different environments, but we can provide flexibility and adaptivity to have the same solution being used in different scenarios and the changing conditions. Where we talk already about the minimizing the use of resources, meaning not only meaning energy, but physical space, material, and so on. Design for scalability and modularity, design for upgradability and repurposability, design for durability. From the point of view of the implementation, this is has not been that much studied. and applied. And this was one of the motivators of the project that I will be talking later. But we also need to consider implementation. What can we do? Well, here there is a list of things. We can use common components. We can use printed electronics or biodegradable electronics, which are techniques which consume much less energy from the manufacturing point of view, and also based on the material. They are not so, we don't need so special elements and materials to do this. It is printed electronics is a very sustainable implementation technology. The use of abundant materials, element, use of ecological and durable parts, use of recyclable parts, avoiding the use of elements, as we said, from conflict areas. And it's not only the material, the elements, the components, but also how do we manufacture them, how much energy and resources we use to manufacture them. So they have also to be taken into account. And in that, from that perspective, these printed technologies is very attractive. So what do we mean by sustainable by usage? So for instance, we use renewable energy sources. We support energy autonomous solutions, meaning battery-less operation. But if I want to do this, I have to have an impact on this, for instance, which this has to be started already from the design phase. We also need to have energy efficient and low power solutions. It also has to be started and decided when we design the whole system. Maintenance-free operation, remote maintenance, again, modifiability, reconfigurability, and at the end of the life, the sustainable disposal, so environmentally friendly electronic waste, repurposability, sustainable recycling. This is also related to the implementation technology. Also, as I said, this sustainability is very complex and multidimensional concept, and people also see this from even wider aspect, like this. Sustainability is related with reliability, with security and privacy, with safety from the point of view of emission of electromagnetic waves, interference, exposure to tissue, for instance. Again, repurposability, cost, durability, flexibility, adaptability, ethics, technological sovereignty. There are many other aspects of sustainability when we think it in a wide sense. Let me see how much used. If we think about where we are now, we will start. We have been already talking about 6G. A lot of work has been done for the last, I don't know, 5-6 years. Now we are facing the standardization phase that probably will start around next year. And so we saw already the IMT 2030 that is recommending also sustainability as a new characteristic of future system. So the question is, are we going to see sustainability figures or specifications or recommendations in the future standard? And what sort of those, at what level do we expect? Of course, this will be very interesting, and it will be supporting the sustainability, and this could happen at the consumer level. And if we do this at the consumer level, meaning like for us consumer, when we buy like a mobile device or something like that, a router or this, but there should be something telling us how sustainable is this. or maybe then at a different level, at industrial or specialist level, like technical details and comprehensive. If I'm an operator, I need to buy some base stations. I can compare this from different vendors from the point of view of this sustainability, how sustainable is this solution, and this could also be from the point of view of manufacturer, it could give them a leading edge, a competitive edge, if we can say how sustainable, and we put a lot of effort in making our system, whatever system, more sustainable. And this will also empower the buyer, us, or maybe an operator, to make an ethical decision about the product. But in order to do this, we need to have some sort of metrics, and sustainability is not so simple to measure. How can we do that, and how can we do it unequivocally and unambiguously, a measurement of sustainability? But if we can do this, this will allow, this will allow us to have some sort of fair comparison between different systems, between different solutions. At any level, again, going from a circuit, if I design whatever circuit or a functionality or a whole system, I can compare it with another. And if we can measure, we can then regulate it, and it could end up in the standards. So this is good. And something like this, some sort of illustration of what could be done at the consumer level. As you know, if you go to the shop and want to buy a refrigerator, you may find this sort of label. Everyone can understand this, even just by the color. Okay, I would prefer to use A and not G, because I know that this is related with the consumption and this energy consumption. But maybe in the future we could have some sort of sustainability level, which gives you a final, some sort of overall sustainability score, which is a combination of different things. How is measured? Maybe we can have also numbers, but we can have part of how recyclable is this mobile phone I'm going to buy, how much energy has been consumed to manufacture it, what is the power consumption, is it upgradable, adaptable? We use some critical materials, something about durability, and altogether this will give you a color, a number. So I can also say, okay, if I'm in shop, I buy this not only based on the looking or on the brand or this, but also this. Now we don't have such a thing. Yes, this is the first part of my presentation, and then I also, this idea of truly sustainability has been around me for several years. I wanted to do something more, but we kind of need some sort of to have some more researchers involved. So we came up with the idea of having a project when we want to work with this sustainability in a holistic way. So now the rest of this presentation will deal into the Super IoT project, which is, as I said at the beginning, SNS project started last year. We are now kind of midway. Last week we had the midterm review, and most of the things that I already said in general, you will see that we are doing our best to apply those in this project. So you can imagine that this is about IoT. Super IoT comes from this, and there are the keywords of the project, which I highlighted here. truly sustainable printed electronics-based IoT, combining optical and radio wireless technologies. I need to drink some water. So we were really lucky that we applied for a SNS project. This was accepted. We have 11 partners, 10 normal partners, one associated partner from the UK. We have academic partners. We have a few SMEs, and we have some research centers as well. And we at the University of Oulu are coordinating this project. And first of all, why IoT? I think that IoT is giving us, on one hand, the great opportunity because of the simplicity of IoT. If I would like to do something like this, like I will be telling you, on a cellular network with a cellular device, which is extremely complex, I think it will be almost impossible, extremely challenging to do this. But with IoT, which is complexity-wise, is quite things we can really design a system, and we have the whole system by ourselves. The technical requirements are not also so demanding. So that was the driving force for going to IoT. But the other thing is, if you see numbers, so as you know, we started like 30, 40 years ago connecting people. Then we extended this to connected computer, connecting machines, connecting vehicles, and everything. But the ultimate frontier of connectivity is connecting everything, like Internet of Things. And if you see, these are some predictions. Some of them, there are many. And today, but this is just some figures of today. They are, depending on the sources, from 16 to 30 billion devices today, IoT. Some conservative predictions say that by 2033, there will be 70 billions, but there are other predictions more aggressive, interesting. ARM predicts that there will be 1 trillion IoT devices in 2035. Some other sources also talk about numbers like this, 1 trillion. This means basically probably more than 100 IoT devices per person if you compute an average. Market size, talking about the overall market size, considering the manufacturing, the service providing. Now already we're talking about 1 billion, but maybe there will be 3 trillions in 2035. These are again predictions. But then the questions are how much energy and material in terms of, let's say, electronic components do we need to manufacture 1 trillion IoT nodes? Do we need to then manufacture 1 trillion batteries for each of those IoT nodes? And at the end of the life, because they have a limited life, what do we do with 1 trillion old devices or obsolete? So we have produced this huge amount of electronic waste. What are we going to do with those? So this was kind of motivation for this project. And so how can we make IoT sustainable? So first of all, as I said, the cost and impact of connecting billions or maybe trillions of devices needs to be considered. Again, we need to use efficiently all the typical resources. Infrastructure is a resource, components, materials, energy, electronic waste, and you name it. So some way of thinking is like to have a sustainable IoT. We can have some sort of using converging infrastructure, able to use and reuse the infrastructure that we have. let's create nodes which are batteryless, energy autonomous IoT nodes. Again, let's use more efficiently different sort of resources, not only energy, to minimize the environmental impact. And as I said, IoT, from our point of view, is the ideal case to start seeing sustainability in a holistic way because of the less demanding requirements, reduce implementation complexity. So in a nutshell, this is the idea of the project. So it is based on dual mode operation. And when I say dual mode is we exploit light and radio. You can see here an IoT system which is connected by light and connected by radio. So we have dual mode wireless connectivity. We can connect using radio, light, or eventually both. We design a system which is the IoT nodes are batteryless, zero energy, and they harvest energy from light and from radio. And they also do positioning based on signals from light and from radio. This will give more enhanced performance, more robust performance. We implement these IoT nodes, only the nodes, using printed electronics. We try to maximize the use of printed electronics. Printed electronics has been around for 20 years. It's relatively well developed, but not fully mature. We cannot buy today whatever we want with component in a printed version. There are many things we can buy, but we cannot buy if we need a processor or high levels of integration. There is not such a thing today. Also, there are some problems with the printed electronics in terms of performance, stability. They are not as good as silicon, but everything is improving, and we need already now to start thinking how to use this and even how to design with underperforming components. And this is part of this project as well. Finally, another key part of this project is reconfigurability. So it is particularly from the use of connectivity, optical and radio connectivity, we can reconfigure dynamically the system, meaning the nodes at the node level or at the network level, and we can choose whatever of those two we would like to use, or eventually both of them. And I have a couple of examples to show. For instance, this is to see how a single solution can be used in different environments or under changing requirements or changing conditions, like change. And this example is for the healthcare. Like we can think about hospital, maybe, and there is these are radio access point, the blue one, and these are optical access point, the yellow or red ones. We can think in this case like this IoT node is just a wearable on the patient. Let's say that we are in an environment that there is only radio connectivity. So if this is the only available access point, of course, we connect by radio, and there is no other option. Maybe we go to or maybe he or she is a patient, she or he will go to a new environment, and there we need high reliability or high data rate. So we can reconfigure the system for this environment to be, for instance, connected by radio and by light. And we use both at the same time. If I send the same information over here and over here, radio and light, so we are using the so-called link diversity, we enhance reliability. but we can also be connected in parallel, sending different information over these two links. So we add up these data rates and we have a high data rate support. Maybe in the third environment, we move to a third environment. There are some very sensitive equipment. This is one case. Or another case would be maybe this is an uncontrolled environment. In this case, this could be a hospital, and there are some very sensitive environment. Or maybe this is at home, the patient at home. No one is controlling what sort of equipment you have there, your neighbors, and this. So there could be problems with the interference. So in that case, of course, we will maximize the use of optical communication. Another option would be like when we are concerned about security and privacy issues, or there are some requirements for that. One way to attack the problem would be to maximize the use of optical communication, because as you know, the optical signal is confined in the environment. So someone outside, he or she won't be able to get the signal. Another way of doing this, and we have been investigating a little bit about this, is to transmit the signal partially across optical and partially about optical and radio. So at the end, you need to have both component, optical received component and radio, and then combine. Someone outside probably will get only some part of the partial information, the radio signal, and won't be able to decode the message. Another case like for this project that we are considering is smart labels and tags. So in the future, maybe we will be able to print the whole IoT node with some labels or like a tag, and we can send information to be displayed, control actuators on the labels, determining, of course, the position of the labels. And we can do this in different ways: unicast, multicast, broadcast. And we can do connections like normal, secure, robust. We decide about this. We have, and one example of this is like maybe in the future we will be print the IoT nodes. They will be printed. Everything will be there. The electronics, printed display, and they will be produced in huge volume that will cost like nothing. So we will be able to have those on any product. Let's say that you go to the shop, you buy a bottle of milk, and there is an area like this, and there is this electronic label. We cannot only just send, let's say, the price, the best before information, but there could be some living text which is moving, that as long as we are exposed to light, we are connected to the internet, we can have such a thing. And then this will be eventually made with biodegradable electronics, so we just throw away and go through the normal recycling. It's not an electronic waste. So this is a vision, but the project is trying to show like we can do it to some extent today. So I return to this figure because this is this holistic approach to sustainability, which we already saw at the beginning, is followed by the project. And how this is done, I just briefly show like like sustainable by design. What we do, this multi-mode communication will have an impact on performance, adaptability, flexibility, energy efficiency, infrastructure reuse. The multi-mode energy harvesting will have an impact of energy autonomy, reliability. The multi-mode positioning will have an impact on robustness and accuracy in the localization. Reconfigurability will bring adaptability, flexibility, repurposability, security, reliability. From a point of view of implementation, basically, in few words, the use of printed electronics only at the node level will bring this sustainable implementation. And from the usage, sustainable usage, smart energy harvesting and management, battery-less IoT node reconfigurability are examples. And finally, sustainable disposal. Again, the use of printed electronics is allowing us to have a sustainable disposal. I want to show now, as I said, we have been already 1.5 years with the project. We started even before the project in our lab. We built such a system. This is only based on optical communications. Let me have some water. This was like the inspiring thing that we did at the beginning. This is light-based IoT. And this is a IoT node. It's not that big, like this size. And we have here a couple of printed solar cells, and this here is a display. So this is kind of mimicking the label that I show you, like we could have in the future on the milk package. Here we see it again, the node. These are the optical access point. And so again, no batteries. We are getting from this light, we are powering up the device, and we are sending information in the downlink, really low rate. We don't need for this sort of application. We are talking about some kilobits per second, which is more than enough to transfer information like this. And we can also connect in the other way around. Let's say, like in the future, if this is label, IoT label in the milk package, if there is one day to the expiration, maybe the milk will send a message to the owner of the shop. Okay, this is getting older. Or if you have it at home, so the milk will send you a message to your mobile from the refrigerator. Drink me, because from tomorrow on I will be getting old. Things like, so this is working in both directions. We started with this, but maybe I show you where we are now. I cannot, because this is a ongoing project, I cannot show you more details about this, but at least a little bit, some photos, and I can spend some time explaining what we have today. We have built, this is experimental, the very first version of the IoT node, which is dual mode reconfigurable. This is the optical transceiver. This is the radio transceiver based on BLE, Bluetooth Low Energy. And but this, as you see it here, is fully made of silicon component. This is the what we call the reference node. Before going to print it, we want to make sure that the idea works with silicon, which we know the best. This is very reliable. So we have this, and now at this point we are testing. Partners are having different measurement setups, experiments with different applications. And this is the node. Like this is the board, on the underneath, we don't see it here, but on the other side, we have this. Here we have a solar cell from which we get energy, and this is a e-ink display. One of the key challenges of this project has been energy and energy management, how much energy we can harvest, and how much and how to use, because we have sensors, we have the communication, and we can do some computing, but it consumes a lot of energy, and we have the energy which is highly limited. What we do is, as you can imagine, we put into sleep mode as long as it is possible, and then we wake up the system and we use whatever communications are computing or sensing, and then we go again to the sleep mode. By the way, there is also, it is not seen here on the other side of the board, there is a supercapacitor, so we store the energy like we harvest there. And the second phase, which is already ongoing, is developing printed electronics components and materials for the device. Again, I cannot give you, I just took the pictures of some devices like because these are still being designed, but these are designed by the consortium. In addition to this, we are planning to buy some commercial printed components to demonstrate some of these ideas. So probably one of the most challenging parts is these thin film transistors. Like we will use them to build some subsystems. Schottky diodes are being developed and tested. Other devices like memory stores, some sensors that we will have on board, everything is printed. Then we have organic, this should be PV cells, not PC cells, photovoltaic cells, and also a micro super capacitors to store the energy. Also, we want to develop the IoT node, which is based on a sustainable substrate. So we are investigating regenerated cellulose to make it of cellulose. And we are investigating, because all these devices that you see here will be interconnected with in that board by using conductive ink. There are a lot of research and a lot of different conductive inks, but most of them are not sustainable. The process consumes a lot of energy, and you need very toxic solvents to deal with this. So the consortium also developing some sort of conductive inks which are sustainable and requires sort of environmental friendly solvents. Another interesting thing that we are doing is, as I said, like let's say that this is the node, IoT node, and let's say it is here, it is harvesting energy for the operation. This is a nice and maybe over-optimistic thinking that the node is just right here. How about if the node, let's assume that we have a network of nodes, not just a single node. How can we guarantee that every node has enough energy? Let's say that this node is maybe here, a little bit in an awkward place, but it could be because it could be moving, because it could be wearable, and it could be obstructed. There is not a good line of sight connection to the source. So maybe some nodes would get, because of the physical location, good energy, they can harvest it efficiently, but some of them not. How to guarantee that all the nodes can have enough energy? So we have been doing some interesting experiments. We are still working on this. Like what we are doing is energy networking. Let's assume that in the future we have, this is an LED, white LED matrix, like you can imagine here. Maybe in the future it will be denser. And some of the nodes will be in good positions. I say this one is just receiving a lot of energy because it is just below the light source. And these nodes could help other nodes, maybe the other one which is has an obstructed view or shadow view, and we can send energy. This node, which is from the energy point of view has a good situation, could send energy beams to the other nodes. And how do we send the beams? We can send light beams, or we can send radio beams, or we can use inductive beams. We have been using these three things. And basically, let's say that this node has is in a good location, gets a lot of energy, more than it can use it. And what to do with this? So, and this node is a little bit in not so good situation, location. So this node will create a link and send, or this node will send through an optical link energy to the other node. So we have built some sorts of cubes where we have solar batteries in different directions. And so, and there are optical transmitters, and we are investigating to do like this node is sending energy to this, and maybe this is relaying energy to this. Of course, this is the same way that we do with data, we do it with energy. The only difference is that the time scales are completely different. When we talk about data, we are talking about milliseconds, microseconds, things like that. Here we talk about minutes, hours, and so on. But the idea is the same. So this is one way to guarantee that all the nodes in the network get enough energy to operate. Also, another example, how about if this node is here, it charges the supercapacitor to full and still is in good condition. It is already charged. You cannot get more energy, but still you are getting light. So then you become generous and you share the energy with others in that case. I have just a few more slides and I will be done. So in this Super IoT, we are demonstrating these ideas through 4 demonstrators. The number 1, we will build some sort of smart label or tag, as I described, with all the capabilities, reconfigurations, things that I said. Just we will have a single node and an optical radio access point, just simple, but we want to show all the capabilities at the node level in a smart label and tag. And then this demonstrator 2 will extend this idea to a medical ICT environment, like where we have like patients, we have healthcare personnel, we have objects and hospital equipment, all using tags based on this IoT concept. And we have at the network level, we will be able to manage distributed resource, a location of equipment, personnel, patient. We can have some sensors and send some physiological. We don't know exactly, we are still in the making. This we are mostly concentrated now on this because the second demonstrator will be based on the use of the first demonstrator. The most demanding task of this project will be the demonstrator 3. I have to say, like these demonstrators, these things that we'll be doing will be hybrid from the point of view of technology. They will have printed electronics, but they will have also conventional silicon-based electronics, because we cannot have today a processor which is printed. There are many components that still are not available printed. So if we want to have a full capability node with everything, we need to resort to this hybrid approach. But in this demonstrator 3, we want to do something which is a fully printed node. It will be extremely simple, quite likely optical. We don't know exactly. We are working on this. And we will use these thin film transistors and some of the components that I mentioned to build something which will be very simple. It is quite likely that it will be based on sort of analog electronic, but we want to see that we can send information and receive, and to show the potential that this idea that having something which is printed is viable. And the demonstrator number 4 will be some sort of additional how to have a RIS, a reconfigurable intelligent surface, to increase the range and the capabilities of the IoT links. So finally, the vision of the project, we believe that we can make fully printed battery-free IoT nodes in the future, like a sticker. Like I attach the sticker to the glass, And that's it. The glass is connected to internet. There are sensors. I can send, receive information, and this. That could be, if produced in large volume, they could be very inexpensive, maybe 1 cent per node. They will be environmentally friendly, disposable IoT node. In the future, also could be fully biodegradable, because this biodegradable electronics is being developed today. It is even less developed than printed electronics in general, but this is the direction that we will be following. And the possibility of having these sort of stickers, IoT stickers, so this will make also possible to come up with this sort of very novel and interesting scenarios. Particularly, we like this massive sensing and massive actuation. We could have these stickers everywhere on natural resources, on the environment, on smart cities, in industry, office, home places, wearables, logistics, smart packaging, appliances, and we can sense and we can actuate in this sustainable way. Other things could be going inside of the human body with connectivity, underwater mining, so on. So, conclusion of this Super IoT, we are trying to show this, like these truly sustainable systems are possible. It's anyway rather humble project. We are just considering IoT, but still there are so many challenges in here. We never pretended that we will do this with a cellular system, as I said, but we are happy with what we have here. In here we have this dual mode, exploited the connectivity, energy harvesting, and positioning domains. We have a reconfigurability. We will be demonstrators, and if you want to follow us, you can follow these links, and you will find something. There is a paper presenting in more details everything. You can find it over there. And well, and my very last slide is a conclusion. So we expect that in the future, sustainability will be one of the key requirements for wireless and mobile communications, as important as today, we have today other performance figures. But there is still a lot to be investigated. And the key questions, how to design a communication system that is truly sustainable, as we discussed, how to consider sustainability holistically, what are the metrics for sustainability. So this creating a truly sustainable system could be seen as one of the key challenges for the future. And we start with something simpler, IoT. So this is more realistic target to start with. And there is a ground to research already in the IoT level with this project. And we hope just to start. And we hope to serve as a model for others. Like, okay, yes, we could also do it, and maybe even better with our system. And so this will create innovation. This is the idea. Thank you very much.